ஸோ லாஸ்ட் பார்ட்டில் ஸ்டாட்டிக் இஎம்ஐ பற்றி பார்த்தோம். இப்போ என்ன அப்படின்னு பார்த்தீங்கன்னா திஸ் டைனமிக் இஎம்ஐ, அதாவது அந்த கண்டக்டிங் பாடி மூவ் ஆகக்குள்ள இஎம்எஃப் இன்டியூஸ் ஆகிறத நம்ம டைனமிக் இஎம்ஐ சொல்லுவோம். தெர் இஸ் நத்திங் பட் மோஷனல். ஓகே, ஸோ ஸ்டாட்டிக் இஎம்ஐயோட கேஸ் என்ன அப்படின்னு பார்த்தீங்கன்னா இட்ஸ் நத்திங் பட் whenever current flows through the coil, there will be magnetic flux and there will be magnetic field and then there will be magnetic flux. It won't induce EMF, no EMF, because flux doesn't change. அப்போ சேஞ்ச் ஆகலைன்னா EMF இன்டியூஸ் ஆக போகிறது கிடையாது. அப்போ எப்போ உங்களுக்கு EMF இன்டியூஸ் ஆகும் அப்படின்னு பார்த்தீங்கன்னா அந்த ஃப்ளக்ஸ் வந்து சேஞ்ச் ஆகும் with respect to time. That is, whenever current changes with respect to time, magnetic field will be also changes with respect to time. Also, flux will be changes with respect to time. Then we can get EMF. Okay. ஸோ இந்த இது ஜென்ரலான இஎம்எஃப்க்கான இண்டியூஸ் இஎம்எஃப்க்கான டெஃபினேஷன். இப்போ இந்த மோஷனல் பார்ட் அப்படிங்கும் போது என்னன்னு பார்த்தீங்கன்னா இட் ஸ்டார்ட்ஸ் மூவிங். இப்போ மூவிங் அப்படின்னும் போது we have set b and theta is equally constant. ஏன்னா flux is depends upon phi, is depends upon b, a and theta. ஸோ அப்போ மேக்னெட்டிக் ஃபீல்டையும் ஆங்கிள் ஆஃப் ரொட்டேஷன் நீங்கள் என்ன பண்ணுறீங்கன்னா ஃபிக்ஸடாக வச்சுருக்கீங்க. அப்போ ஏரியா மட்டும் நம்ம அல்டர் பண்ணுறோம். தென் இட்ஸ் காசஸ் மோஷன். அப்போ அந்த மோஷனால் இன்டியூஸ் ஆகிற இஎம்எஃப் நம்ம மோஷனல் இஎம்எஃப் அப்படின்னு சொல்கிறோம். ஓகே, இதை புரிஞ்சுக்க என்ன பண்ணலாம் அப்படின்னு பார்த்தீங்கன்னா ஜஸ்ட் கன்சிடர் ரெக்டாங்குலர் பார் லைக் திஸ். ஓகே, ஸோ ரெக்டாங்குலர் பார் இன் perpendicular magnetic field to this plane. Okay, so magnetic field எப்படி இருக்கும்? So it will be into the plane. Let us consider cross mark. That is magnetic field is into the plane. Since it is a uniform magnetic field, so it should be uniform throughout the region. So that is your uniform magnetic field. Okay, so this is your B vector cross. So in your movable conductor இருக்கிறதா assume பண்ணிக்கலாம். இந்த regionல ஒரு movable conductor இருக்கிறதா assume பண்ணிக்கலாம். So let me give some names. என்ன அப்படின்னா இந்த part P and this point as Q and this point as R and this point as S. So it is PQRS, a rectangular core. Okay, இப்போ we will move this bar, that movable bar PQ இருக்குல்ல. So the P to Q portion is said to be, it is said to be movable. It is said to be movable bar. So the movable bar we will move with the velocity v. So in this direction. அப்போ நீங்க என்ன பண்ணணும் அப்படின்னா induced EMF ஓட direction first கண்டுபிடிக்கணும். For this we have to use thumb means right hand rule. In this right hand rule, thumb represent the direction of the motion of a conductor and index finger represent the direction of magnetic field on this plane and then middle finger represent the direction of induced current. அப்போ நீங்க இந்த two factors இருக்கு. One is nothing but magnetic field, another one is nothing but motion of the conductor. So we will use this factor, that is motion of the conductor along this direction. Magnetic field is into the plane, so like this. So middle finger shows this direction, that is current will flows from S to P. So current direction எங்க இருக்கு பாத்தீங்கன்னா S to P இருக்கு. So this is explained using the rule called from instruction rule. So once திரும்ப again I will என்ன அப்படின்னு பாத்தீங்கன்னா since magnetic field is into the plane, அப்போ index finger into the plane place பண்ணுங்க. Motion of a conductor is along this direction. அப்போ இண்டெக்ஸ் நம்மளோட மிடில் ஃபிங்கர் எங்கே பாயிண்ட் பண்ணுது பார்த்தீங்கன்னா upwards, that is S to P. அப்போ S to P கரண்டோட ஃப்ளோ என்னவா இருக்கும் பார்த்தீங்கன்னா S to P, then P to Q, Q to R and then R to S. So it will be along the anti-clockwise direction. So current will induce in the movable rod, that closed path, that is PQRS. So current flow will take place from P to Q, first S to P, then P to Q, then Q to R and then R to S. So this is the direction of current flow. The current flow is along anti-clockwise direction. Okay, the current flows along anti-clockwise direction. So this current is explained by the law called Fleming. This is a rule actually. Fleming's right hand rule. The hand should be important because the last part moving coil, moving charges and magnetism, and the part என்ன பண்ணிருப்போம் பாத்தீங்கன்னா Flemingோட left hand rule யூஸ் பண்ணிருப்போம். அங்க என்ன அப்படின்னா it is not induced current, அது force experience by charge பார்ட்ல கண்டுபிடிக்கிறதுக்கு யூஸ் பண்ணிருப்போம். So the right hand என்ற கான்செப்ட் வந்து ரொம்ப important. So it is said to be right hand and then it is said to be right hand rule. So this is an important factor. Okay, so exact அது என்ன quantity என்ன variations explain பண்ணனும் தெரிஞ்சுக்கணும். So just I will again elaborate it. So your thumb represent direction of velocity and then your index finger represent direction of magnetic field and then your middle finger, so index finger and then middle finger represent your direction of induced current. Okay, so இந்த மூணு ஃபேக்டரையும் ப்ராப்பராக ஞாபகம் வச்சுக்கணும். ஓகே, ஸோ நெக்ஸ்ட் அது எவ்வளோ இஎம்எஃப் இன்டியூஸ் ஆகிருக்கும், தட் இஸ் குவான்டிடேட்டிவ்லி. இஎம்எஃப் இன்டியூஸ் ஆகுதுனால கரண்ட் ஃப்ளோ ஆகுதுன்னு தெரிஞ்சிச்சு. அப்போ அந்த குவான்டிடேட்டிவ் ஐடியா என்ன அப்படிங்கிறத பார்க்கணும். ஸோ திஸ் இஸ் நத்திங் பட் இஎம்எஃப் இஸ் said to be we know that according to Lenz's law it is negative n, it is d phi by dt. So this is our expression according to Lenz's law. Since we know that number of turns is said to be 1, just considering a single turn, so it is nothing but EMF induced is said to be negative of d phi by dt. So this is your EMF induced part. Okay, so what is flux? Flux is nothing but we know that since we know that phi is said to be it is b times a. It is b times a. Since the angle between them is said to be 90 degree, between area and the magnetic field is said to be 90 degree, so it is cos of 90 degree. That is, it is b times a. What is a? Area of this loop. Since area is said to be length into its breadth, so we will consider this portion as our breadth and this portion as our length. So it is L into B. So therefore, it is nothing but B times L into small b. So this is our magnetic flux. So if you substitute in this EMF equation, we will get that motional EMF part. That is, EMF is said to be negative of d by dt. What is our phi? Phi அப்படின்றது it is B, L and B. So capital B, length into breadth. So in the movement factor, என்ன factor vary ஆகுது பாருங்க. Vary ஆகுற factor என்னன்னா length remains as length. ஏன்னா PQ arm வந்து நீங்க far away move பண்ணும்போது the breadth வந்து increase ஆகுது. So therefore magnetic field is fixed there. So I'm just keeping it as out. And length is also constant. So varying factor is said to be dV by dt. This B is nothing but breadth. Okay. So displacement by time is said to be velocity. So that is given by the term called V. So therefore, since we know that since V vector is said to be d L by dt, that is displacement. Okay. So it is nothing but we have to express in this minus form. So that is V vector equal to dl by dt. So it is nothing but B L D. So this is a motional EMF induced in this problem. So that is quantitative idea, and then other qualitative idea. Qualitative means our direction in the. So in motional part, we will go to about the parameters. For parameters, nothing but what are the quantity related to the induced EMF? It is nothing but EMF. Whatever we derive is it is B V times N. So this is our motional EMF. What will be the induced current? If current on the flow in the EMF impact, if current flow. Simple Ohm's law. We know that I is equals to B by R. So induced current equation is BV L by R. So this is our induced current equation. So this is our motional EMF, and then this is motional current, motional EMF, and this is motional current. Motional current is nothing but that induced current. Okay. So current can flow or magnetic field region. So you have magnetic same diagram draw on. So this is our magnetic field region, that is B vector cross L, and the PQ mobile arm draw on. Remaining on the consider. So in here P, Q, R and S. So that S arm, P to S arm, that movable arm. The velocity in the direction magnetic field into the plane. And we know that whenever current flows along this direction, induced current in anti-clockwise direction flow again. Last result. Okay. Current in the direction there will be magnetic field around the coil. So whenever current carrying coil produces magnetic field around the coil, upon the magnetic field, external magnetic field interact. Upon the interaction result, it will experience a force. Either it will be an attractive force or it will be a repulsive force. Okay. And the force experienced by a current carrying conductor will be expressed. It is F vector equal to I times L vector cross V vector. Okay. So since the length element magnetic field angle on the 90 degree, we will get the result as F is equal to I times LB. Okay. So this is a force experienced by a current carrying conductor in a uniform magnetic field. Okay. The current expression is substitute in result. So F is nothing but current is said to be B V L by R, and then it is L times of B. Okay. Because this relation has some L times of B. Instead of this I, we can substitute this factor here. B and L. Okay. We can relate the result as this is B, B square and then L square by R. So if flow force on the experience arm, this is said to be force experienced by the PQ arm. This is the current flows through the arm P to S, EMF induced in the arm P to S, force experienced by the arm. Force experienced by the arm PS. Okay. So this is motional EMF, current flows, and then force experience in the uniform magnetic field. Okay. How much power required by this magnetic field to pull this or to make experience this force? That power is given by the relation. Power is said to be force times velocity of that moving arm. The force equation direct time is substitute. It is said to be V B square L square by R. So apply direct result is substitute. Then into V. Already over V. So power will be B square L square by R and P. So this is the relation that is said to be power exerted by power exerted by that external or this is said to be B external in this field. External magnetic field and the rod மேல exert பண்ற power factor. Okay. So since we know that in electricity we have learned that ஒரு current carrying conductor இருக்கு அப்படினா whenever charge flows it will generate heat energy around the coil by the concept called Joule's law of heating. That is, we learned that I square RT, which is also equals to V square by R into T, which is also equals to it is a V I into T. So this is expressed by the law called Joule's law of heating effect. Okay, Joule's law of heating. Okay, Joule's law of heating. இப்போ எவ்வளோ ஹீட் எனர்ஜி உங்களுக்கு டிசிபேட் ஆகும், that is it is related by the term called P of J, that is power. Okay, it is said to be EMF times current. What is the factor EMF? It is dVL. What is the factor I? In the part அப்படியே இந்த substitute பண்ணிங்க. Okay, it is nothing but it is said to be dVL and I என்ன அப்படின்னு பார்த்தீங்கன்னா I is said to be dVL by R. So it is dVL divided by R. அப்போ பவர் என்னன்னு பார்த்தீங்கன்னா it is also V square L square by R. So this is said to be P of J. அதாவது power dissipated when current flows, the induced current flows. This is nothing but power dissipated when induced current flows. Induced current flows across PS. And the PS வழியா induced current flow ஆகும்போது this much heat will be generated. அப்போ இந்த ரிசல்ட் நீங்க கம்பேர் பண்ணீங்க அப்படின்னா என்ன ரிசல்ட் ரைஸ் ஆகும் பாருங்க. It is exactly equal. That is என்ன மீன் பண்றாங்கன்னு பார்த்தீங்கன்னா நம்மளுடைய electrical energy, mechanical energy is converted into electrical, then electrical energy is converted to thermal energy. So the whole concept explains the law of conservation of energy. Okay, so first factor, that is mechanical energy is converted into electrical and then it is converted into thermal. This thermal energy. Okay, so in the whole factor என்ன explain பண்றாங்க பார்த்தீங்கன்னா that is law of conservation of energy. So this concept explains the law of conservation of energy. Okay, so ரொம்ப இன்ட்ரெஸ்டிங்கான ஒரு கான்செப்ட். we connected law of conservation of energy, that electric joules heating law எல்லா பார்ட்டுமே ரிலேட் பண்ணி உங்களை கம்பேர் பண்ணுங்க. So the EMF பார்த்தீங்க அப்படின்னா emotional EMF is generated between the rods when the rod moves in a uniform magnetic field. இப்போ அந்த EMF நம்ம டிஃபரன்ஷியேட் பண்ண விதம் அதை டிரைவ் பண்ண விதம் வந்து ஃபர்ஸ்ட் லென்ஸாக வந்து நம்ம கொண்டு வரோம். இப்போ லென்ஸில் ஒரு ஐடியா இல்லாமல் equilibrium of force experienced by the charge of the conductor as well as electrical force. இதோட balancing mechanism வச்சு we will do the thing. Okay, so let us consider that there is a charge. Okay, there is a charge. இப்போ இங்கே induced current அதை flow ஃபாலோ பண்ணுங்க. induced current ஓட மாடல் வந்து S2P, like direction of induced current is said to be S2P. Okay, then S is said to be higher potential, then P is said to be lower potential. Okay, அப்போ இதை பாசிட்டிவ் டேர்மில் எடுத்துக்கலாம். நீங்கள் இந்த டேர்மில் என்ன பண்ணலாம் அப்படின்னா நெகட்டிவ் எடுத்துங்க. இப்போ மேக்னெட்டிக் ஃபோர்ஸோட டிரெக்ஷன் என்னவா இருக்குது அப்படின்னு பார்த்தீங்கன்னா direction of magnetic force using Fleming's left hand. That is, your magnetic field is into the plane, so it is into the plane, and motion of the conductor is said to be along this direction. So the magnetic force point பண்ண direction பார்த்தீங்க அப்படின்னா just considering the charge here, magnetic force point பண்ண direction here, that is your F of m vector. Okay, electrical force பார்த்தீங்கன்னா since it is positive, அப்போ negative என்ன ஆகும் பார்த்தீங்கன்னா there will be an attractive force. அப்போ இந்த directionல electrical force will be that. This is F of e. So what is your F of e அப்படின்னு பார்த்தீங்கன்னா it is charge times the electric field. What is your F of m? Force experienced by the current carrying conductor. So it is given the relation I times of L times B. Okay, so it is I times L into B. So it is I times L into B. Okay, so we can equate these two relations. That is the cross product of these two factors. Angle between them we know that. Appo at the equilibrium, your electrical force is also equals to your magnetic force. Okay, so that is charge times electrical field is equals to I times L B. Since angle between the length element and the magnetic field is said to be 90 degrees, so sin 90 is 1. Upon the relation simply equal to I times LB. Okay. Since we know that EMF, voltage, potential difference, that is, it is nothing but electric field between these two regions is said to be potential of the rod divided by length. Okay, potential divided by length. So, okay, if you cross multiply this factor, that is Q times of V by L is said to be I times of L into B. Okay, this I times of L into B. So since I is said to be Q divided by T, so it is Q V L and then I is said to be charge flows per second and then it is length times its magnetic field. So these two factors getting cancelled, இங்கே L by B இந்த velocity of the rod. So it is nothing but V by L is nothing but V into V, velocity of the rod times V. ஏன்னா அங்கே length by time, that is charges flow in the length divided by the time the rod velocity. So that is V is said to be it is BV and then L comes here. So இது நம்முடைய potential. Potential between the rod and EMF induced. அப்போ இந்த factor நீங்கள் எப்படி எக்ஸ்பிரஸ் பண்ணலாம்? EMF induced is said to be it is BV L. So what will be the induced charge that flows through the conductor? So induced charge we can express like this, that is according to Snell's law, induced EMF முதல்ல relate பண்ணலாம், that is delta phi divided by delta t. So according to Ohm's law, what is the induced EMF between these two rods? That is current flows time resistance, that is E times of E equal to I times of R. Simply I times of R is actually resistance of that rod or movable arm PS. So now we can equate, so let us consider as equation 1 and equation 2. If we equate panninga appadina, we will get a relation, that is delta phi divided by delta t is said to be I times of R. And minus column and is said to be modulus of the factor. Okay. So if we rearrange the given factor, that is delta phi is said to be I times of delta t into resistance. Okay. நமக்கு தெரியும் என்ன அப்படினா, that is current is nothing but it is the rate of flow of charge divided by time. Appo what will be the rate of flow, what will be the charge? It is current into that interval. So we can relate this factor here. அப்போ relate பண்ணீங்கன்னா I by delta t is said to be Q, that is delta Q times resistance. So delta Q is said to be delta phi divided by R, that is modulus of flux, because that minus an induced EMF உடைய direction நம்ம mention பண்ணிருக்கோம். So இந்த equation கான meaning என்ன பார்த்தீங்கன்னா, it is said to be induced charge. So this is induced charge factor. Okay. So last topicல dynamic EMF பத்தி பார்த்தோம். அந்த dynamic EMF வந்து whenever a rod moves, dynamic means motion. அப்போ motional EMF generate ஆகிறத பத்தி பார்த்தோம். இப்போ periodic means it doesn't be constant or it move பண்ணாம it starts rotating. Okay, translate ஆகல, அது மேல rotate ஆகுது. அப்போ rotate ஆகும்போது அது generate பண்ற EMF தான் நீங்க என்ன சொல்றீங்கன்னாக்கா periodic EMF. அப்போ அந்த EMF factor periodic EMF அப்படின்னு நோட் பண்ணுறோம். ஸோ நமக்கு தெரியும் flux is nothing but B times A cos theta. So அப்போ flux is function of BA and theta. மூணு ஃபேக்டர் டிபெண்ட் பண்ணி இருக்கும்போது we are just keeping A and B as constant, then phi varies with respect to time. So theta varies with respect to time. Okay. Because of this, EMF is flux is also changes with respect to this factor. Because of this, EMF is induced. That EMF is called as periodic. So it is said to be periodic EMF. Okay. அப்போ the periodic EMF நம்ம எப்படி calculate பண்ணலாம்? How to calculate this factor? So let us consider that there is a uniform magnetic field in this region. Okay. So we will consider north as well as south, a bar magnet. So our rectangular coil on the glass. So this is our rectangular coil, and then it is externally connected just for power supply connect. Okay. So we will name it as P, Q, R, and then S. Okay. So uniform magnetic field is along this direction. So B vector is along this direction. Okay. Then okay, it flows along this direction. Okay. If we start rotating in any one of the direction, so current will induce us in this path. So this is given by the rule called Fleming's left hand rule. We can find the direction of current using the motion of the connector. We can find the direction of current. Okay. So therefore, the flux equation is rewritten like this. That is phi equal to it is B times of A cos of theta. So we can't put theta as 90 degree. So we have kept in some position. We are rotating with respect to time. அப்போ theta in function of time we express பண்ண பாத்தீங்கன்னா, we have to relate a term called omega, that is angular velocity. Angular velocity is said to be angular displacement by time taken. From this relation, what is theta? It is omega times of t. So if you substitute it here, so phi is said to be B times of A cos of omega t. So in this case, I have taken only one term. For n number of turns, for n turns, so for n turns, flux is said to be n times of B A cos of omega t. So this is your flux relation in terms of periodic case. Okay. So we know that what is the EMF generated? EMF generated is expressed by the relation that is negative d phi by dt. That is changes with respect to time. So if you substitute it here, that is d by dt is nothing but n ba cos of omega t. Since we know that n is constant, we have fixed some 500 from 1000 like that turns. B is said to be a fixed magnetic field between north and south pole. A is said to be area of the loop doesn't changes. So it is n b a that is d by dt of cos of omega t. Okay. So cos differentiate we know that it will be negative sign. So it is negative ba, that is negative sin of omega t into that time is function. This function of time but has some constant factor called omega. So if you multiply this factor, that is negative will be positive n b a omega sin of omega. So this is our induced EMF generated in case of periodic case. Okay. So there is a constant factor, that is NB times A. That will be the peak value achieved by the EMF. So it is expressed by the relation, that is E of naught, it is sine of omega t. So E naught is called as peak value, that is it is given by the relation NB and A omega. This NB A omega. So it is named as peak value. So if we graph we will get a sinusoidal function. So we will get a function like this, a sinusoidal function. So sinusoidal function with a peak value, that is E naught along the positive direction, because this is time axis, and then y axis is going to be EMF axis, and this is said to be negative E naught. So it is said to be 0 at the origin, and then at pi is also, that is 180-degree rotation, that is the positive half of the cycle, it is also 0, and then again it is a full rotation, that is 2 pi, it is also 0. So it is maximum at 90-degree, that is pi by 2, and maximum negative maximum in an angle 3 pi by 2. Okay, this is a sinusoidal function. How to get that induced? This is said to be induced EMF. This is induced EMF. That induced EMF is said to be a periodic case. It is developed in a periodic case. Okay. What will be the periodic current? That induced current, because of that there will be a current flows, right? That is given by the relation I is said to be E divided by resistance of the coil. Okay. So if we substitute it here, that is E naught sine of omega t divided by resistance. Okay. In the factor, in the question is substitution. So E naught by R is said to be a constant, that is called as I naught. It is I naught sine of omega t I. So we obtain an induced current relation in terms of periodic case. Okay. So this is our induced current. Induced current in terms of periodic case. Okay. So these are all the major ideas used in, or we have learned in induction, that is electromagnetic induction. So it's nothing but 3 cases, that is static, dynamic and periodic. So all the topics are covered. Okay. Thank you.